All right, this is for Chemistry CP, a debrief on a homework assignment of drawing Lewis dot structures. First, number one is for bromine. Bromine is a halogen, so each bromine atom individually has 7 valence electrons. There are 2 bromines, so the total number is 7 times 2, which is 14 electrons. So we need 2 bromine atoms. They are going to share at least one covalent bond that takes care of 2 electrons. Now we still have 12 electrons to take care of. If I put 6 of them on each of the 2 bromines, then each bromine is satisfied. They have 8 valence electrons counting the shared pair. 8 valence electrons counting the shared pair. Next, methane is the common name for CH4. Carbon has 4 valence electrons and just 1 carbon. The hydrogen has 1 valence electron and there are 4 hydrogens. So 4 plus 4 is equal to 8. Following the rules, we should put the carbon in the center of our structure. Hydrogen is going to have a single shared bond, single shared bond, single shared bond, single shared pair, I should say. I've just used up 8 electrons. Each hydrogen is satisfied because it has the 2 valence electrons that it wants. The carbon is satisfied because it has the 8 shared pairs of electrons that it wants. Number 3. I don't know the name of SiH4. I could call it silicon tetrahydride. Silicon, like carbon, has 4 valence electrons. Each hydrogen has 1. So once again, we have 8 valence electrons. And I would say that there is no difference in substituting the silicon for the carbon in the structure that we generate. So here I'm using up 8 electrons in 4 pairs. Each hydrogen has 2 electrons by sharing. The silicon has 8 electrons by sharing. Life is good. What is presumably number 4 is CBrFH2. C is carbon, it has 4. Bromine is a halogen, it has 7. Fluorine is a halogen, it has 7. Each hydrogen has 1, and there's 2 of them. So that leads to 2 electrons for that. 7, 14, 15, 16, 20. I would put the carbon in the center of the structure. For the hydrogens, bromine being a halogen is only going to bond to one other atom. Same is true for fluorine, same is true for the hydrogens. So therefore, I'm going to start off by attaching each of these 4 atoms directly to the carbon. And by symmetry, I would have the hydrogens opposite each other. They're small. They fit, squeeze inside better. So right now, so far, I've just used up 2, 4, 6, 8 of my 20 electrons. 20 minus 8 means I still have 12 electrons to take care of. They're not going to go on the hydrogens. The hydrogens are already happy. So I'm going to divide these 12 electrons evenly between the bromine and the fluorine. Put 6 on each one of those. And that molecule is satisfied. 8 shared electrons for the carbon and 8 electrons for the bromine, 8 electrons for the fluorine, 2 for the hydrogens. Life is good. C2H6 is a carbohydrate, is it? It has a name. I don't remember. It goes methane, and then whatever this one is could be propane. Then there's butane and so forth up to octane and beyond. So each carbon has 4 electrons. There's 2 of them. So that means I have 8 electrons from the 2 carbons. Each hydrogen has 1 electron. There are 6 of those. So I have 6 valence electrons from the 6 hydrogens. 8 plus 6 means I have 14. Draw the structure and check. Hint, in this, both the carbons are central and they have 3 hydrogens each. Well, that tells us what's going on. Carbon is going to bond to carbon, and there's going to be at least a single bond. Maybe it's going to be double. Maybe it's going to be triple. But based on this hint, each carbon is going to take 3 of the 6 hydrogens. So 1, 2, 3, 1, 2, 3. As drawn, I have 2, 4, 6, 8, 10, 12, 14 electrons used up. Each hydrogen has 2 electrons, so they're happy. Each carbon has 8 electrons, so they're happy. This is perhaps propane, whatever it is. Dihydrogen monoxide, also known as water. Each oxygen has 6 valence electrons. Each hydrogen has 1. There's 2 hydrogens, so 2 electrons. So we're working with a total of 8 electrons. The single oxygen should go in the center. We're going to draw the hydrogens as being opposite the oxygen, although later in the course we see that they're actually at an angle, and that takes care of 4 of the 8 electrons. The other 4 electrons would be distributed on the oxygen. And this will do as a Lewis structure based on our current level of understanding when you did this homework assignment. 8 electrons around the oxygen, 2 for each of the 2 hydrogens. Life is good. This is a polyatomic ion known as ammonium. The plus sign means there is 1 fewer electrons than there are protons in the situation. Nitrogen has 5 valence electrons. Each hydrogen has 1 valence electron, and there's 4 of them. So altogether, we would expect there to be 9 valence electrons. In fact, the 5 for the nitrogen would go here, the 4 for the 4 hydrogens would go there, and now, due to this charge imbalance, the loss of 1 electron, we subtract 1 electron from 5 plus 4, which means we have 8 valence electrons total to work with. As is our habit, we're going to put the nitrogen in the center. Hydrogens will only bond to one other atom, so I would distribute each hydrogen directly to the nitrogen. In this situation, I have 2, 4, 6, 8 electrons surrounding this nitrogen, making him happy. Each hydrogen has 2 shared electrons, making them happy. But to show that this is a polyatomic ion, I'm going to put square brackets around it and then a superscript plus sign, reminding the viewer that this particular polyatomic ion is not an electrically neutral molecule. It is a 1 plus charged polyatomic ion known as ammonium. SO3 with a 2 minus charge. Sulfur has, like oxygen, 6 valence electrons. Each oxygen, like oxygen and like sulfur, has 6 valence electrons, and there's 3 of those. 6 times 3 is 18. In addition, there are 2 additional electrons making this a polyatomic ion with a 2 negative charge. So we have to add 2 to our total number of electrons to come up with 26 electrons in this situation. I would begin by putting the sulfur in the center and try attaching an oxygen to the sulfur as a thought. This uses up 6 electrons. I still have 20 more to take care of. If I put 6 on each oxygen, that's 6, 12, 18. If I then put the last 2 on sulfur, that will take care of 20 valence electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. There's our total. Again, showing the world this is not a neutral molecule, but instead it has overall a 2 negative electric charge.